I'd suggest we get started, Jamie. So thank you all. I hope you had a great Thanksgiving holiday and welcome back to work. And welcome to the first Surge webinar series hosted by the Electric Vehicle Center. I'm Alan Taub, a professor of material science and mechanical engineering at University of Michigan and director of our Electric Vehicle Center. For those of you who are interacting with us for the first time, we were awarded in 2023 with $130 million from the state of Michigan and another $20 million from the university to really build on our history of working with companies on automotive technology and specifically to enable the successful transition of the industry from ICE to BEV vehicles. Our vision is quite simple. We plan to keep, and depending on your point of view, or maintain or make Michigan the e-motor capital of the world. And we are doing that on three pillars: technology development, education, and workforce. And in addition, expanding our facilities. On the technology side, we've already had 2 workshops dealing with the onboard components, well attended by both faculty and companies, and in fact are presently launching 11 technology projects based on those workshops. And what we're trying to do, kicking that off today, is introducing the technology and workforce and general needs on the infrastructure to enable the electrification of the fleet. And what we're doing is having a series of 3 webinars to really make clear what are the challenges, what are the opportunities on enabling that transition. I'm pleased to introduce our inaugural speaker, who's Jeff Myrom. He's Director of Transportation Electrification Programs at Consumers Energy. They are a member of our center. Jeff leads the PowerMIDrive and PowerMIFleet programs, and they're basically driving EV adoption through innovative approaches, particularly focused on getting off-peak charging, consumer engagement, and expansion of the infrastructure. PowerMIDrive has already achieved over 90% off-peak charging participation among residential users, and they won the 2023 Peak Load Manage Alliance Pacesetter Award. And Consumers Energy is really driving and advancing the EV infrastructure across Michigan. Jeff is a Michigan Tech graduate and over 20 years experience, sustainability and environmental leadership. He lives in Haslett, Michigan with his wife and 2 sons and enjoys exploring the Midwest in his electric vehicle. Please join me in welcoming Jeff, and now I'll turn it over to him to begin the presentation. By the way, we'd ask everybody to hold their questions till the end, or you can real time put them in chat, and we will get to them after Jeff has finished his talk. Jeff, all yours.
Sounds good. Thank you, Alan. Really appreciate the invite to be here today. And yes, I'm an EV driver as well. I've been driving an EV for over 6 years now. Multiple different vehicles. So if you have any questions about EVs as well, happy to answer them. I drive over about 20,000 miles a year, and I've never gotten stuck or run out of charge. So happy to say that. So I'll get this up and rolling. A second to go to full screen. Okay. Well, thanks for coming out today, everybody. Really appreciate being part of the inaugural launch of the webinars today. And hopefully the future ones are just as entertaining and good. Today, I want to talk about our Transportation Electrification Plan, or TEP. This might be a new acronym which is out there, and how it plays into grid considerations and what we're thinking about. So Consumers Energy just moved into permanent programs in this space. We've been running pilots for several years. And as Alan was saying, we've got 2 of those, PowerMIFleet, which focuses on fleets, of course, and PowerMIDrive, which focuses on both residential and public infrastructure. So we want to give people charging confidence wherever they're going to be or however they're using their vehicle, that they know where they can go. They've got the ability to recharge and continue on with their journey. So to start off with, I kind of want to give a macro view of the grid and where it runs to, and also what's going on in your home or business on that side. And this graphic here is really a simplification of the grid on the left all the way down to the electric vehicle on the right and what's in between it. And I'm going to start on the left because I get this question all the time. And the question is, can the grid handle electric vehicles? And I am personally not very concerned about the grid handling electric vehicles. I think with good planning, such as what we're doing, future projections, and keeping an eye on where the industry is going, we can be well prepared. I commonly hear things like this theoretical question of, well, what if everybody adopted an EV today and they all plugged in? Could the grid handle it? Well, that's a theoretical question. It kind of reminds me of, you might remember Y2K, which obviously was quite a while ago, but there was this fear at that time that everybody would pick up the phone at midnight and the voltage would drop and the telephone system would crash. Electric vehicles are not that kind of situation. When we think through consumer behavior, vehicles last a long time. I think the average vehicle in Michigan is over a decade old, probably closer to 15 for a total lifetime, 15 years for a total lifetime that vehicle's there. So people aren't rushing out and buying an electric vehicle every day. There is steady upward growth for sure. But if we think about how long it's going to take to frankly get to that transition, even if you assume someone buys an EV every 5 to 7 years or buys a new vehicle every 5 to 7 years, it's going to be into the early 2040s, if not mid 2040s, before we have large mass adoption where the potentially majority are on the road. So if you think about that load growth over that amount of time, if the entire light duty transportation sector were to electrify, that's maybe 30%, maybe a little bit higher load growth over that time. So 20 years, 15, 20 years of load growth, that has easily been done. And if you look back at kind of the history of the US grid, especially post World War II and industrialization, which happened then, much more rapid load growth than through electric vehicles. It's really building a kind of a castle, one grain of sand or one brick at a time, as opposed to a big chunk that's coming in, for example, such as like a new AI data center. That's a very different situation than with electric vehicles. So the bulk power system on the left, the transmission grid, even most of the distribution network that leads to your home or business is not really a significant concern. Where this starts to get interesting is what we call the grid edge, which is right here in the middle. And the grid edge is a nice marketing term, to be frank, of where the utility infrastructure ends and your home infrastructure, your business infrastructure begins. And that's right at the meter. So that's perhaps something you want to do tonight when you go home after work. This would be my challenge to you at your house is go check out your panel. That's going to be on the opposite side of your meter, somewhere on the inside of your house, or your fuse box, you might call it, and look and see if you have space for another double bar breaker. So that's going to be like your electric oven, your electric dryer. Typically, this is going to be 50 amps that you're going to put in a 50 amp breaker for that electric vehicle that you may have in your house. If you don't have room for a double breaker or more than one, maybe even 3 or 4 breakers, you may need a panel upgrade. And that's where this starts getting interesting for the customer, be it a business or a home, because everything on that side of the panel then on is your responsibility. And that's where you would hire an electrician to get that in. And so these constraints aren't really grid specific. These constraints are site specific. And one of the things we do in our program is really try to help people right size this, because this can be a major barrier to adoption. And frankly, most people aren't thinking about their electrical infrastructure in their home or what it might cost for an electrician to come out and do that work. But it really dominoes. And it starts with the EV and what you choose to charge it with. So there's a saying in vehicle manufacturing that weight begets weight. So if you have a really heavy vehicle or large engine in a internal combustion engine vehicle, you need bigger brakes, you need a bigger frame, you know, all this stuff. It gets heavier and heavier. Well, with electric vehicles, with the amount of energy that you need, the bigger the charger you put in, the more that impacts you. So some of the most unhappy people we see on the residential side are those who maybe get an electric truck, um, and they think, oh, I want to get the 80 amp, uh, the 80 amp charger, which is going in, not realizing at all that that is almost assuredly going to require a panel upgrade in their home. It's going to add a couple more $1,000s with that electrician work, which is there. And frankly, if you're getting 8 hours of sleep a night, or at least hopefully you're home for at least 8 hours a day, your vehicle doesn't need that. Unless you are a very long distance driver on a very regular basis. The typical person is 40 miles or less a day. 7 kilowatt, level two might be all that you need. Um, we have two EVs in our house. We only have one charger. It's a dual cord charger. It's off a 50 amp circuit, NEMA 1450 outlet, and we do both vehicles just fine. And like I said, I drive over 20,000 miles a year electric. We could probably even get a 30V on our circuit and save money. My oldest son is a teenager. He's driving my car now, but at some point he might get his own EV. I've got another son who's not far behind him, and we've already thought this through. Like, it's very doable to do with just one dual plug charger on a 50 amp circuit. And that saves thousands of dollars compared to putting in an additional circuit, putting in additional infrastructure, upgrading that panel. Now, for a business, it's the same thing. If you're a smaller business, maybe you're a pharmacy delivering, um, you know, one or two vans that are doing deliveries out to neighborhoods, or a florist, or a small parts shop, very easy. You might be able to fit that into your panel just fine. Now, if you're a larger business, like let's say an Amazon or FedEx or Postal Service, where you're going to be putting in hundreds of vehicles, this grid edge connection here is actually not even part of the equation, because we're going to be doing a new service. We're going to be dropping a new meter, a new transformer for you for the size of that load, and it's going to be designed from the get-go to handle that larger vehicle. So these or those larger number of vehicles. So these constraints, there's ways to work around them. There's ways to think about them. And we really want customers to right size what they're doing. And we can help coach people through that to save you a lot of money. And of course, the reason why a lot of businesses are going EV is because it's about half the cost per mile. So if you are a high mileage business, or the more you drive, the more you save compared to a petroleum fueled vehicle. So a great setup. All right, so that's kind of the macro view of the grid and the constraints and how we help walk people through those challenges. Now we want to think about load growth at the right time. And so this is getting more specific, again, getting down to that grid edge component. And what you're seeing here in the blue is kind of a load curve. So a load curve is how much energy is the typical home using per day? And at different hours of the day, you're using more. So not surprisingly, this is a 24-hour clock time here on the bottom. In the middle of the afternoon, you're getting home from business, especially if it's in the summer, you're going to have your air conditioning running. Maybe you're starting to cook dinner, the kids are all hopping on their devices, all those things. You get what's called peak load, and that's the top of the blue curve there on that energy load. An EV, or multiple EVs, if you add those in, can exacerbate the peak. Now, if in our system, there's about 6 homes for every transformer. So if one or two of those homes, maybe even 3 of those homes, are charging on peak in the middle of July or August, it's not a big deal. It's within the safety factor of the transformer serving that neighborhood. However, as we get to larger amounts of societal adoption, and more people in the neighborhood have EVs, and we do see EV growth as being viral, the neighborhoods that tend to have them tend to get a lot more because of that familiarity factor. Everybody on my street, to be frank, has driven my EVs. They've all been curious. If you're an EV driver, you probably know this too. People are going to ask you about your car. They want to experience, they're kind of curious. Maybe they don't necessarily want to go to a dealership or a sales environment and talk about it, but somebody they know and trust, they will. And you may even be nice enough to give them a test drive. I would encourage you to do that, because familiarity is one of the biggest barriers to EV adoption. So if we get to that situation, and we can imagine that happening in the future, what we're concerned about as a utility is trying to get people to avoid exacerbating the peak, because this only happens a couple hours out of the year, the entire year. And so if we're upgrading the rest of the bulk energy system to accommodate mass adoption on peak growth, that's very wasteful. I mean, 98, 99% of the time, the grid will not be used more for that peak. And so we can save a lot of money and improve reliability just by getting people to shift over into those, the valley time period, which tends to be overnight, year round. And this is not just good for the grid, it's good for all customers. And let me explain this a little bit. So even if you're not an EV driver, this benefits you. And that's because rates are dollars per kilowatt hour. And so let's dig into that a little bit. The dollars just represent all the infrastructure, all the generating power plants which are out there to ensure that you get electricity when you want it. So if we can do the exact same infrastructure with more kilowatt hours going through it from the vehicles, it brings down the dollars per kilowatt hour. And a lot of people don't realize this. Electric vehicles can actually be a downward rate pressure uh, development for everyone. It's completely positive, not even looking at the environmental benefits or the new high tech jobs which come with electric vehicles, huge benefits on the electric side. So, this is what we're all about. This is what we want to encourage people to do. And when we tell people, hey, by charging off peak, not only are you going to save money because we have off peak rates that are lower, about 20% lower in the overnight time period, but you're also going to be helping everybody else in Michigan who's on the grid and keep costs down. They react very positively to that. It's a great message. All right. So, what's our next part of the strategy? So, we've talked about the bulk system. We've talked about um, charging at the right time. Another key aspect here is this the segments or the locations at which people are going to charge. And this is incredibly important from a managed charging scenario because the typical person, the typical household probably has close to $40,000, $50,000 in vehicles in their garage. And if you look at the stats on vehicles, they are parked the vast majority of the time. Some estimates well over 90% of the time parked. That means people put a huge psychological value on being able to go whenever they want to be able to go. That is not economically optimized by any means, but it is the way we all live, and it is the way that we're kind of wired to be. And so when we think about where do we put charging infrastructure and the level of that charging infrastructure, it's important because this will impact adoption. It will impact people's desire to be part of a managed charging program. So the blue and the green right now are all parts of our permanent program. And this pie chart is an initial projection of where we thought total load, at least proportionally, would land by 2030. We're pretty close, but I think we've underestimated the direct current fast charger, which is what the DCFC stands for. That's actually been a higher proportion than we thought. In this graphic, we thought it'd be around 15%. It's trending, frankly, closer to 30% because once people get comfortable with their vehicles, they are taking them on those longer distance trips. And when they have confidence that the infrastructure is going to be there, the charging infrastructure is going to be there along their way, they're very happy to do it. So that's important for unlocking it. But let me kind of go through the blue and the green here a little bit. So fleet in the blue, what we're seeing right now is largely light duty fleets. Uh, there will be some semis coming forward, and I think in the next 3 to 5 years, but the economics right now are really in that light duty segment. And these are typically delivery fleets, which are coming in, parked overnight. They're charging, they're getting loaded up with boxes overnight while they charge. Another awesome thing is you can do this all in-house, so you can be under the roof. There's no carbon monoxide emissions or other emissions. And so when we first started helping people site or uh, where these fleets could be, I was looking at some aerials of warehouses and counting the parking spaces outside, and I'm like, you don't have enough. There's not enough room. But I was thinking, and the old way of thinking. The new way is you just drive them right inside, plug them in, and fill the boxes while they charge. So interesting land use observations as well on fleet, but they're highly motivated to save money, and so sticking to that off-peak schedule and when the rates are best, going very, very well on the fleet side. So that's been going great. Residential single family is going to be our biggest segment because about 2/3 of our customers live in a single family home. About 1/3 live in a multifamily situation. And again, for the single family, 2 to 3 cars, 150 amp circuits save a lot of money, plus the $500 rebate that we have. Folks are really engaged, and that load growth is pretty close, or that load is pretty close to what we've been predicting. Multifamily has been a little bit less. I think this is going to pick up in the next 2 to 3 years because if you look at market trends, about 40% of EVs right now are leased, which means 2 to 3 years from now, a lot of used vehicles are going to be on the road. And a lot of people are also not aware we have a used EV tax credit. Hopefully that's still here, or some type of incentive in the next couple of years. But that's a very economical way to get into the electric vehicle segment. And we want to make sure we're prepared for when the multifamily growth really starts to happen. So the ideal situation is being able to charge at home, whether that's multifamily or single family. But we know, especially in the multifamily space, that this can be challenging. Maybe there's not significant an easy way to get electrical infrastructure into your underground parking area or the parking lot, which may be behind there, or you may have a property owner who's just not interested in investing in that. And so we've tried to address that by having some fallback situations. One is community charging, which means just a public parking space, could be on street, could be a public parking lot, ideally within 1 to 2 blocks of a multifamily property, so that people can still charge overnight in a safe space for their vehicle. That's actually been going more strongly than the residential multifamily. And then the other one is workplace, because if you can't charge at home, if you can charge at work, that can also enable you to do that. I have a person on my team. He charges his EV at work. He doesn't have a charger at home. Works great for him, can work out just fine. But we've got to make sure that that charging infrastructure is there. And then the third one in that category, in that super light green, is destination, which is more like your hotels. Maybe it's your ski resorts now that we're getting dumped on with snow up north. If you can drive there and plug into a level 2, as opposed to trying to find a fast charger, and you're going to be there overnight, or maybe you're skiing all afternoon, or you're going to a conference and you're going to be there all day. That's a great way to have a much lower power impact, where that load is spread out over a longer period of time, and you're charging while you're doing something else used and useful. And so that can be an incredibly cost-effective way to go. So those are our core strategies. And where we're leaning into this year with the rate case, and we expect to get approval for this next year, is battery energy arbitrage on the fast chargers, both for fleets and for public. And now that we've had several years of data on what fast charging looks like, very little is happening overnight. It's about 2% or less, which is happening overnight, not a surprise. So the complete inverse of all these other categories in blue and green. And demand charges, which is a component of your bill, which basically means, like, if you really spike up in energy during a certain part of the day, there's a fee that goes with the total kilowatt that happened during that, and it's basically charged per month. So if you can get rid of the demand charges, and we can get the load smoothing, and then there's some reliability aspects of this as well, where you might have backup power for your convenience store, for example, or your grocery store. Those are really good extra value added use cases which can tie into there. It's still developing. I'm not going to say it's economic right now, but we're proposing some rebates in this space, and we're trying to help push this as well, because we do see it as a great growth area. It's also incredibly important for the user experience. You don't want to show up at a fast charger and, with your family on vacation. And I've been there when my kids were younger. They're tired. You want to get to the hotel, or you want to get home, and you certainly don't want to get to the fast charger and find out, oh, we're going to be here for an extra 30 minutes because the utility decided to call a load management event. That would be an absolutely horrendous user experience. So that's top of mind for us when we think about how do we get into this space, either behaviorally or from a technology standpoint, to make it work. And so we are the first really utility in the United States that doesn't have legislative enablement, which has this full portfolio of a program out there. And I'm really proud to say that. And I do want to thank the MPSC staff for their collaboration as we think about what are the best areas to put this infrastructure and how do we implement it for customers. So how's it been going? All right, I am very happy to say this has been going incredibly well. Our residential side, both single family and the multifamily, I put over 95% here, but we average closer to 97% off peak. And that's huge. And we're doing this through a very low tech methodology, which is surprising to people. There's plenty of high tech, high cost, high complexity offerings which are out there. But we won the Peak Load Management Alliance's Pacesetter Award last year for being the top utility in the US for load management with this simple approach. It's a $500 rebate on your home level 2. Again, that's that 50 amp outlet, just very similar to your oven or your dryer. $500 is about half the cost. So if you've just bought a car, you've got a car payment, and now you're looking at $1,000 for installing a level 2 in your home, and we can come in and say that's a 50% discount. That gets people's attention. Otherwise, they are not paying attention to utilities. We are not a top of mind industry, except for when the power goes out or there's perhaps a gas emergency of some sort. Most of the time, we are completely subconscious for how people think about us. So we need a strong hook to get people in to participate in the program. So that $500, that 50% off your home level 2 install, then allows us to have a conversation about the right sizing of the infrastructure for the vehicles you have, how many vehicles you might get in the future, and also hook you up with an electrician who knows what they're doing. There are plenty of people who will install an EMA 1450 on their own. The biggest mistake is they don't realize what the electrical code says. And the electrical code says this is a continuous use, so it has to be industrial continuous use rated. You want to go out and you want to buy the $100 NEMA 1450. You do not want to go out and get the $15 one at Home Depot, because that one is made for your oven, which is going to pulse on and off as that heating element comes up and is only used for a couple hours of the day. Your level 2 at home might, on a day you show up with 5% because you drove back from Chicago. I live in the Lansing area, so I can get home with about 5% in the summer. It's going to be going for 8 hours straight, and you need to be prepared for that. So it lets us have all these conversations with the customer, do that educational outreach, and achieve those high results. And then the other thing we do is we give people a $10 a month incentive for 12 months. So it gets you through all 4 seasons. So it's another core question that folks have is, can I survive on this level 2, even when it's cold out, even when it's 0 degrees or less, and make it happen? And this is a way, basically, to behavioral conditioning to show that, okay, you get this relatively small incentive, but it's enough to convince people, okay, yeah, I'll try the off-peak rate. I'll see if I can make it work in the super off-peak time period. We give you 3 times a month where you can charge outside of that and still get your $10. And when you graduate in a year, we see people very high correlation continue on with that off-peak charging. So we know these programs are working, and it's very low tech. It's just using our existing smart meters and outreach and education and time of use rates with about a 20% differential on that night to daytime time period. Very similar thing with fleets, so I won't go through that exact same story. And then on the public charging, on the level 2 public charging, like I was saying with destination or workplace, we're picking locations where the use case matches the off-peak time period. So, for example, if I drive down to our headquarters, which is in Jackson for Lansing, I can plug in at our headquarters. I'll be done by 10:30, well before the afternoon peak. Most people will. There are very few vehicles that will, or very few commutes or drives that will lead into that on-peak time period in the afternoon. So that's the right kind of place. If we put these at hotels or places where people show up on the weekend, like those ski resorts I was saying, you are going to get very high overlap correlation with that off-peak time period. And so it matches the use case, it matches when we want the loads to fill in the valley. And our total portfolio is more than 90% off-peak, which is absolutely top-notch. So level 2, I've spoken a lot about that, and hopefully I've given you some reassurance that with some very simple planning, this is a very solvable problem. I now want to turn to an area where we do need some more work and we do need some more investment, and that's on the fast charging. So this is the direct current fast chargers, or the DCFC, if you've heard of that. I did this one thing, and I'm glad I did it, where I got onto PlugShare. I would encourage you to get onto PlugShare if you haven't before. Look at this app, look at places you drive, and find out where your fast chargers and your level twos are at those destinations. So that even if you drive a gas car now, if you're thinking about an EV, you can start scouting them out, because you're probably driving right by them and not noticing or even thinking about them because you're not actively looking, and they don't necessarily stick out. So in 2020, when we started our program, I did this screenshot on the left of fast chargers that were 50 kW and up, 50 kilowatt and up, and the combined charging standard, CCS. We have since helped over 80 fast chargers come into our territory, which covers most of the lower peninsula. I know I'm not showing the UP, so no offense to the to any Upers in the crowd, but I'm just trying to focus on our territory. We don't cover DTEs, which is of course largely the Detroit, greater Detroit area, or down towards Chicago, which is Indiana, Michigan, in the southwest corner of the lower peninsula. But everything else, except for a mix of some munis and some co-ops, is our territory. So a lot of these orange plugs that you're seeing, we have helped put in, and it's a huge change. I can tell you, having been an EV driver before 2020, when there was largely nothing north of Grand Rapids and Lansing except for Tesla, and Tesla wasn't open to CCS vehicles, to today, it is night and day. And most people aren't realizing this. So I want to show that just in a few short years here, a huge change in infrastructure, and we see this accelerating even more, which again is why we're leaning in on that battery arbitrage and trying to prepare for that, because fast charging sites now aren't just one or two plugs. We're talking about 8 dispensers, 12 dispensers. There's one at O'Hare, which is over 50 dispensers, and so they're becoming bigger and more powerful, though I think the number of dispensers is more important than continuing to go up in kilowatt, because it gives people confidence that when you show up, that there's going to be one available. And even if one isn't working, the other 7 are. That gives drivers confidence, and that drives adoption. So we want to be ahead of the curve on the fast charging infrastructure. So I'm nearing the end here. I think I only have a couple more slides, and then I'll open up to questions. But on the left, this is our forecast of different futures which could happen. The green is our portion of the state goal. The state of Michigan has a goal of 2 million EVs by 2030. We're about 40% of the population in Michigan is in our territory. And so that correlates to close to a million. It's actually about 950 some thousand on this graphic. It doesn't equate at a million. But if we were to hit the state goal, that would be the green line. We had McKinsey, who's a consultant, come in last year and do a projection for us and where they thought growth rates were going in Michigan and our territory. They peg it closer to 630,000 by 2030. And then our integrated resource plan, business as usual, which is more of a conservative case, so kind of the low end of growth, is around 500,000. And so we looked at these bands, particularly the McKinsey to our IRP projection, and we did some benchmarking. And in particular, I looked at Tesla and the Tesla Supercharger network, because it's by far the most mature network which is out there. This is not a commercial for Tesla, but when you're trying to benchmark and see like where things are going, you want to look at some of the leaders in the industry, and they have the most fast chargers out there. And the ratio of superchargers to Teslas is about 1 for every 85 vehicles. And so we looked at that. We looked at the size of the number of dispensers which were going in at those sites, which again is like 8 or more on that. And you very quickly get to some projections of very large growth. So I just talked about, probably well over 100 in total across the state, which have opened in the last couple of years. But if you look 3 years out, 5 years out toward 2028, 2020, 2030, thousands, potentially 1,500 to 1,800 sites, which are a megawatt or greater. Now that's specific, and I'll kind of give a reference point because a lot of people don't know what's a megawatt. A megawatt is your typical big box store. So if you go to a Myers, if you go to a Target with a grocery, or a Walmart with a grocery, their peak load is around a megawatt. So when you think about putting a fast charger site in the parking lot of that business, you're basically dropping a mire within a mire. You are putting a whole bunch of load right there, and that's not a small deal. This is not a level two. People don't build a big box store every day, and so the transformers that go into your neighborhood or your small businesses are produced in much larger numbers than the transformers that go into these larger load sources because there's not as many made every year. And the entire world is going electric. And that's not a joke. China's like 50% EV sales. I just read the article this morning that Norway is now closer to 95% EV sales. Most of Europe is around 30%. So even though we are around closer to 2 to 4% in Michigan, we can look at these other growth rates and say, yeah, this is absolutely where we need to go because this is going to take off. And these transformers are 24-month plus wait right now. So we're working on pre-ordering these. We're working on refining these projections to make sure we've got this infrastructure ordered and ready for when the customers want it, even though they haven't asked us yet for it today. And again, we also want to lean on that battery strategy because if we can downsize some of these transformers, especially in our more rural sites or smaller towns where they may not need a megawatt type capacity for that load, we can help them be prepared and do that energy arbitrage and that reliability on that front. So let me close out here with costs because this is another myth buster out here, and I want to circle back to what I said earlier about the off-peak charging and the margin from that off-peak charging saves everybody money. And so what this is looking at the additional revenues coming into the utility on the low scenario, the 500,000 EV scenario. And the stacked bar is our program costs, which are the blue that we're recovering from the rate base. And the green is the additional margin, which is going to downward rate pressure. I hope this makes it incredibly obvious that EV adoption is a net benefit for Michigan and it's a net benefit across the United States. If we can get this off-peak load growth, if we can work on energy arbitrage, the technology improves, we will do incredibly well with this load source. And what this also means is right now we're using about 20% of the additional margin for our customer programs, largely for infrastructure, both residential and out in the public at your workplace or your destination. But there's room for even more investment. And this is why us as the auto state, the e-mobility state, as Alan was saying, other states like Colorado and New York, they have legislation very similar like energy waste reduction, energy efficiency, which says utilities, you shall do this, or you should have this plan. Michigan, frankly, in my opinion, could really use very similar legislation to those states targeting utilities because right now consumers, DTE, yes, we're heavily engaged in this, but many other utilities are not. And there is definitely an opportunity here for both more infrastructure investment with this kind of margin and still save downward rate pressure for all customers. So I think I did pretty well in the timing there. If you want to find out more, there will be a copy of this presentation, I'm sure, sent around, but consumersenergy.com/EV will get you to all our rebate and incentive programs if you happen to be in our electric territory. If not, I know DTE has some programs as well. And if you want to read our transportation electrification plan, there will be a link there as well. I know it probably doesn't, copying that probably doesn't work on your screen, but when you click through, it will. And with that, I'm going to stop sharing. I'd be happy to answer any questions.
Yep. So Jamie Ratcliffe, our communications director, will manage this. Either raise your hand or we do have at least one question in the chat, which we can start with. Jamie.
Yeah, Jeff, we have a question from Jim in the chat. How are you identifying all the small to medium-sized fleets that may not appreciate the need to contact their utility with current and growth plans?
So, yeah, that is a great question. It's a little easier on the residential side than it is on the business side. So we're trying to get the word out there. But frankly, most customers will come to us when, and I guess I can say this because I've seen it multiple times. They will order some electric vehicles. They will then start engaging with a charging provider who's going to put in their charging infrastructure, their level 2 or the fast chargers, and they'll quickly realize they need a new service because most of the time it is oversized and it is too powerful for what their needs are. And so when they engage with our customer energy service team, that gets them dovetailed in with us, where we can then reach out to them and say, hey, not only can we help you save on the right design or give you some advice on the design and what we think of it, but give you some rebates on top of it. That's where it starts to happen. But we do need to definitely get the word out more. We are working with multiple dealerships, the ones who are interested in working with us, so that they have QR codes that they can share and rapidly get people to our program. Um, and so that's how we've been doing it. On the residential side, we can actually use our smart grid data, our smart meters, and look for spikes in energy use. So we're not necessarily looking for a load shape, but we're looking for a 5 kilowatt or more spike at some point during the day, because that's uncommon. It's uncommon to turn that many things on in your home at once. And that gives us about an 80+% confidence that that home likely has an EV. We can then send a postcard or an email, not in a big brother sense, but in like, hey, Consumers Energy has rebate programs. Um, very, very generic. So it's a very friendly approach, and we get great response from that as well.
We have another question in the chat. Is power quality and specifically harmonics an issue for the grid when increasing the number of EV chargers?
It hasn't been, and we're optimistic that it won't be, but I think, again, that's where some battery and energy storage is going to help. I also think we will get to a more sophisticated, at some point, a more sophisticated load management system, which in my opinion is more likely to come through the OEMs. For example, right now we have mostly early adopters who are in the program. They're engaged. They're technologically tend to be more savvy on that front. But at some point, we will get in the bell curve of adoption where there's folks who absolutely aren't interested in engaging in a load management program or kind of knowing the behind the scenes of what's happening with what's going on. But they may very well be willing to engage with the app for, let's just say, their Ford or GM app on their vehicle. And if there's some gamification on there, for example, like, hey, would you be willing to slow down your charging or stop charging right now, or let us start you at a certain time during the night, and for that you get, a free Big coffee or some kind of credit when you go charge next time. I think we will get people, and so I think that that more load diversification is going to be very helpful in the future. But we're certainly keeping an eye on it as we go forward.
I have another question from Harry. If a company installs their own microgrid with battery storage and solar, do you see Michigan utilities trying to take advantage of that capability in the future?
No, not well. Okay, I guess it depends what you mean by taking advantage of. I do think more and more customers are going to do that for multiple reasons: costs, reliability. Depends what type of business you're in. Might be critical infrastructure which you're involved with. Well, what we might be getting at is like, will there be bidirectional power flows? And can we use that? So from a grid perspective, being your own microgrid or being able to microgrid yourself looks a lot like demand response, which is, traditionally where you would turn off a production line or you would turn off some part of the energy in your home, like cycle your air conditioner at longer time periods. So yes, I think it can still very much pull into demand response type programs. From a bidirectional flow perspective, costs have really got to come down on that infrastructure, I think, before we see mass consumer adoption. I mean, you're talking about 5 times the cost, sometimes 10 times the cost to do it within your home. It's probably very similar within a business. So if those costs come down, I can see greater adoption. But your peak home in Michigan in the summer with your air conditioning going is already using around 10 kilowatt. And the highest vehicle to load capability right now that's in a commercial vehicle that I know of is the Ford F-150 Lightning, which can do right about 10 kilowatts. So you're putting back into your home almost what that max peak might be on that peak day of the summer. So you might not ever even get to where power is flowing beyond your home. And so I think when the market really needs it, it's going to look more like demand response than it is through bidirectional power flows. And then the other thing that I think is going to be really interesting to see is MISO is already not Texas or California, where you have a grid which isn't necessarily the best designed, and you see these big swings in prices. I mean, you want to look at price swings on the independent system operator market, like Texas. Take a look at that. MISO is much more moderated. And when you start putting utility scale batteries, especially paired with solar and wind, which are already DC, so talking about DC to DC connected generation, I think you're going to see even more moderation on those prices. In addition to just being able to take those intermittent sources and making them look a little more baseload like, not full baseload, but more along those lines. So where the market goes, stay tuned. But we're keeping an eye on it, and there's a lot that can happen with technology adoption.
Andrew's asking, what are the projections on the demand for wireless dynamic charging infrastructure in both public and private settings?
Yeah, so wireless, I think, is interesting. It's not as efficient, of course, as directly plugging in. So you do have some losses on that front, but it's more the either convenience or the use case factor. So, for example, like in a parking garage, you might pull in and maybe people don't want to mess with cord management and all those things. Could be very useful in those kind of situations. For public transit, where you have small stops on a regular, frequent basis, where you might be sitting for just a couple minutes, that could be another area where I think the wireless inductive charging could be quite positive. Myself, I probably wouldn't put it in my home because I know there's losses. I know there's losses with it, and I'd rather just save some money. But maybe the typical consumer won't think that, and convenience will outweigh it. So again, I think it's going to be a fascinating future to see where it goes.
Chris put in the chat that commercial utility rebates are quite robust in Michigan. However, most stakeholders, end users, developers, engineers, architects, contractors are totally unaware that they exist. Is marketing and messaging currently one of the biggest challenges?
We very much are trying to do that. So we get in, if we can get in with the trade association where we can speak to hundreds of people at the same time, that is absolutely fantastic. We just gave a presentation to TICOM, which is a acronym from like a tourist industry conglomeration in Michigan. A lot of hotel owners, a lot of resort owners, and tried to talk to them about our destination charging program. We've been able to do that with some multifamily, especially as they're building new ones that are out there. We just had a facility or a multifamily in Grand Rapids, new property that's going to have 20 level 2s in it. So I'm more optimistic on the new construction that will get people engaged, and that's really the most cost-effective thing to do it. But there's still a lot of word that needs to get out on obviously existing buildings and existing infrastructure and getting that charging in their parking lots.
One more question in the chat. Any comments on what you might be doing behind or in front of the meter to prepare for climate resilience or even the periodic polar vortices of the Great Lakes region?
Yeah, so that is going to be fascinating because we might see, I mean, nobody talks about wind chill in the summer. And so I think it's going to be really interesting to see, do we get hot still time, even more hot still time periods in the summer, and also with increasing of the water cycle, will it also be more cloudy? So those things are things that in our integrated resource plan, which is a separate team from me, but I'm a component that goes into it, they think about those weather aspects and how they play into what future generation, meaning solar, wind, other technologies, battery storage, what are the different ratios of that we're going to need in the future to be prepared for what might not be a common occurrence today, but could be a much more common occurrence 10, 20 years or longer from now. And those IRP plans typically look at 40 to 50 years out. However, having, been on the IRP team in a prior utility, I used to work for Berkshire Hathaway before coming to consumers almost 12 years ago now. I was on the IRP team running those models. Technology changes so much that your first 10 to 20 years of those modeling projections are really by far your most accurate. Everything you're doing beyond that is kind of what ifs and kind of thinking through, perhaps should you relicense your nuclear plant for another 20 years as a contingency on those fronts. But yes, we definitely have teams of experts weighing in on those situations.
Great. Thanks, Jeff. Why don't we turn it back to Alan to wrap things up so we finish on time?
Yeah, so Jeff, thank you for our inaugural Surge webinar. I learned a lot, and it was a fantastic overview. We have, and hard to do, but virtually, I'm sure everyone is clapping their hands, and I'm sure there is a way to show that in reaction. I do want to clarify that we have 2 other sessions, as December is our focus on infrastructure. Jane McCurry from Clean Fuels Michigan will be doing a presentation also on the challenges for the infrastructure December 10th, and Richard Muller from DTE on the 16th. And then we go into the new year where we'll have a life cycle assessment and what is the implication of the conversion of the fleet and the impact on CO2 of the grid and emissions by Greg Keolian from the University of Michigan. I would like to also ask people to put a hold on their calendar for April 1st and 2nd, which will be our first annual EVC symposium. It'll be in Ann Arbor at the Michigan campus. And so looking forward to that. And the way to register, we are going to capture all your emails and make you aware of this. Again, Jeff, thank you so much. And thank you, everybody, for joining us. Looking forward to the next session.
Thanks for having me, Alan.